Hello everyone. Today we will present the new feature of the Slab Design Assistant in Safi. The assistant can be started by selecting the Edit Slab Design Strips button in the Mesh Contour Perimeter menu. It is also possible to toggle the visibility of the design strips in the X and Y axis once the generation is completed. The new assistant presents a 2D interface of the contour of the slab. The new menu allows the quick generation of the design strips in two different axes of the concrete slab. We will now generate the design strip for this short example. The automated generation is done based on the support detected in the model. The supports are then represented by these boxes with an X in it. The strip generation is done in two separate steps. First, we need to define the column line in the slabs. They can be automatically generated by using this button. Next, once the strips are properly generated, the automated generation of the design strip can be done with this button. The column lines are used to define the geometry of the design strip in the slab. They are also used to guide the location of the column strips within the slab. The Generate Column Line tool allows us to automatically connect these supports that are aligned in both the X and Y axes. The advanced generation option of the column line will be explained later in the video. There are also several addition tools that allow you to manually modify the column line within the slab. It is possible to delete a column line, add a column line in the X or Y axes. We can also select a column line to see their different properties on the left side of the interface. We can see the identification number, its direction, and the coordinates of the different points forming the column line. We can extend a column line to the sides of the slab. We can add and remove points to a column line, and we can cut in two segments a column line. The generation of the design strip is done by the detection of bidirectional baseband within the slab. In the assistant, they are automatically detected when two horizontal column line frame two vertical lines. In this model, we can see that there are 5 different bays. We can then generate the design strip in the model. The advanced generation option of the design strip will be explained later in this video. Once the design strips are generated, we can toggle the view for both the X and Y axes of the strips. By deleting some sections of the column lines and restarting the generation of the design strips, we notice that only the central part is generated. If we complete another bay by adding the missing segment of the column line, it would then also be generated. If we complete all the missing bays by adding the missing column lines, all the design strips will be generated since all the bays will be completed. Again, as a reminder, the automated generation is possible when two horizontal column lines cross two vertical column lines. In order to allow the automated generation of the column line, supports need to be detected in the model. 3 types of supports are automatically detected as supports in a Safi model. The point constraint can be placed in the model directly from the Finite Element Mesh Generation menu. The linear constraints are added from the same menu and can be used to represent a wall in a model. They are detected as support on both ends of the linear constraint. If you already have supports defined by members perpendicular to the slab that are already defined in the model, this will also be detected as support. In the interface of the assistant, we can see that the supports are displayed by different symbols, but will be detected the same way. Now let's take a look at a little more complex model. This slab is supported by several vertical supports as well as 4 walls. There is also a stairwell opening in the middle of the slab. Let's start by opening the Concrete Slab Design Assistant. Here, we have a 2D plan of the slab along with its different supports and opening. By launching the automated generation of the column line, we can see the advanced parameter for the generation. These parameters are optional and have default parameters that will suit most models, but it is still possible to modify them if needed for more complex models. The first parameter is the maximum angle. It represents the maximum angle of deviation between two supports. By default, the angle is set to 10 degrees. The second parameter is the maximum length of the span. This parameter defines the maximum length of each segment automatically detected for a column line. By default, the maximum length is set to 10,000 millimeters. Once we start the generation, we can notice that not all supports were detected. This is caused by the angle between the two supports being too high. Let's go see in the model the actual angle between these supports by using the measurement tools in SAFI. We see that the actual angle is 13.34. Hence, the default angle of 10 degrees was too low to allow a complete detection of the column strip. We can also verify the maximum length of the span here is 8,520 millimeters. We can restart a generation of the support with a maximum angle of 15 degrees to take into account the larger angle between the supports in the model. The maximal length doesn't need to be modified. We can now see that all the column lines were properly connected in the central portion of the slab. Now let's start the generation of the design strips of the slab. We can notice that the four corners of the slab are not covered by the design strip. This is caused by the horizontal column line not completely joining the vertical line in the similar way at each corner. This can be easily corrected by using the Extend Line to Sides tool on these two lines. We can now restart the generation of the design strips of the slab. As we can see, after closing these segments, design strips are now generated in these areas. Also to note, it is possible to switch between the view of the x-axis and the y-axis at any time. The width tolerance addresses the maximal difference of width between two adjacent strips. If two adjacent strips have a width gap less than the specified value, they will be fused during the generation. This operation is done on the left and right side of each strips individually for more precision. If we define the width tolerance as 0 millimeters, there will not be any merge of strips during the generation. Let's take a look at what happened in this specific strip. We can notice that most of the segments in this strip are closely similar, but are all in different design strips. For design purposes, it could be advantageous to merge all these strips into one of the same width. By generating these strips again with the default value of 500 millimeters, we will have a uniform width strip. We now have a uniform width column strip. We can also notice that the strip in the central part of the slab has not been merged since its width gap between these two adjacent strips is greater than the 500 as the width tolerance value. Let's go ahead and enter 2000 as the width tolerance value. We can now see that all the strips are of the same width. This, however, tends to reduce the width of the middle strip, especially if the strips aren't completely straight. It is also possible to adjust the length tolerance criteria. Any strip segment with a length lesser than the criteria will automatically be merged to an adjacent segment of greater width. The default value is 3000 millimeters. The use of these different parameters will allow you to easily generate the design strip in a concrete slab. Also, to help you complete the design of reinforced concrete slabs with greater efficiency. Here are a few other examples of projects that have been completed with the help of the Slab Design Assistant. Thank you for your attention. Please stay tuned as there will be more videos to come in the near future.